And so let's see what we did with them. So check them and see where your questions are. Go down to at least this far and tell me if you have any questions so far. Be careful. Remember you need to separate the products before you bring down the power. It's going to keep whatever base it is, it's going to keep that base. Ashley?
For 53, that says LNZ, right?
LNZ.
Okay.
That looks a little strange, yeah, sorry. You guys don't write script, right? No, nobody writes script. I can't believe you guys didn't learn this.
We learned it.
I can only do my
Did learn it?
I learned it like we learned it in third grade, and then they were like, "You're always gonna have to use this," and then next year they're like, "You don't have to use this."
Yeah. Like a few years back, I did one of the PSATs on a Saturday, and the kids had to sign. They had to rewrite this whole paragraph in script. Oh my gosh, it took longer than doing the whole SAT, the whole PSAT. They couldn't write script. Yeah, they were writing in print and then connecting the lines. Yeah. I can't believe you don't learn script. So I'm sorry. I'll have to be careful.
I can read it.
You can read it. Yeah. Yeah. I'm the product of the Catholic school, so we scripted like in first grade. But I'm also a Catholic school lefty, so I had to write with my right hand because I was evil to write with my left hand. So that's why my handwriting stinks. All right, so try these. How did these work out for you? Again, get this radical out of here, make it a fraction. Bring down your fraction before you do the divide. If you want, you can distribute it or you can leave it like that. This, why did they put this in here? Why is that there? Think, where did your log graph go? What's your domain for your log? 0. 0 to this. But why would they do this? Why would they say greater than 1? So it's all positives? Well, yeah, I can't. Can I put a 0 in here? Can I put a 0 in here? Can I put a 1 in here? What happens with the 1 in here? It'll make your numerator 0. So can I use a 0 log of 0? No. So they just, all it is a qualifier. It said it only works in this condition, when x is greater than 1. Do you have to worry about that? No. Yep.
Where you have ln x minus 1 plus 1, I made that ln x squared minus 1.
You left it at that?
Yeah.
Okay. I'm not too concerned about that. This is your perfect square, so you can separate them. You wouldn't be able to do it if it was a plus 1. You'd have to leave it like that. But try to look for anything that you can factor and you can make a product. Sometimes you really don't see those until we get to the equation parts. Yes?
Are you allowed to distribute for 61? To ln, like for the final?
Okay, so we're...
Like all the way at the end, can you like distribute that or no?
Distribute this?
Yeah.
In terms of what?
We'll like add the two together?
No.
Okay.
No, yeah, no. Because remember we tried this? Did we do this? Remember we tried that in your calc and said, doesn't work. Not the same. Yeah, that part you can't do. And whenever you get an argument like this, like just say it said ln x squared plus 1, there's nothing else you can do to that. You leave that. You're just looking for products, quotients, power rules, and roots. Most of these, you'll probably see a little bit better. You'll know how far to go when we do the equations. Because when you get to an equation, then you're going to take your x squared minus 1 and separate it to x plus 1, x minus 1. Okay, we're back just to condensing. Remember when you condense, You're going from 2 down to 1 term. 1 term, or as many, if they have 3 terms, 4 terms, you're condensing these down to 1 term. Right? Everybody okay with this? That last one was a little bit more involved. Work from your inside parentheses to your outside parentheses. So first thing you're going to do is combine this piece. You're going to combine this piece into 1. Then this 2 goes outside of this. Okay, so it's actually, you have to do this piece first before you can square it. And then you've got a quotient. Just leave it as quotient. Did you have to do this? No. If you saw it, yeah. If you just leave it factored, that's fine too.
Do we have to do that last part for it?
This part?
Yeah.
No. If you do this, that's fine. If you could see that that was your perfect squares, that's good.
So the practice for saying 6 plus 2 next one is 2 squared, right? Because I thought the 2 meant that only the x.
So just this part right here is when you added your exponents, you were multiplying your bases, right? So you're going to bring this down to a product. Just bring it down to a product first. And now this 2 out here goes outside of that whole parentheses. Whenever you get a bunch of parentheses, nested, brackets, work from inside out. Okay? And how about the last part? Just to kind of give you a little bit more. Get used to your ln again. You can bring, technically you should actually bring this power down first. And then it's going to reduce, so I just kind of skipped a little space. Good? No? What part? No. Come down. What is the only thing that's going to get my exponent down? Is a log rule. So what should I do? This looks like this one. Maybe we should have looked at something like this first. If I did 2 to the x, I might say, oh, does this drop down to a power of 2? Let me try that. If not, and I can't drop it down, how am I going to get this down? With a log. So you would put logs on both sides. And instead, you could put ln on both sides. It doesn't matter. For ln, you can use for everything. When it's an e, you have to use ln. But ln, you can use all the time. Most college books will always use ln. Now, I can bring down my exponent. So as soon as I bring my exponent down, I can say, okay, divide by log 3. P.S., there's no dividing this. There's no dividing 72 and 3. You have to say log 72 divided by log 3. And now you can do this one. So when I'm here with base e, I have to use an ln. So I put ln on both sides. Now this is one of your properties. ln and e cancel out to 1. First you should bring your x down. ln and e cancel out to 1. It's kind of a mess there, I'm sorry. So x is equal to ln 72. Now, well, here's the thing. If I tell you where to round to, then no. And usually in pre-calc we round to 3 positions. If I ask for an exact value, then you would have to leave it like this. But most of the time in pre-calc we round to 3 decimals. So you would just put in your calculator ln 72, and you would come up with this. 3 positions. This, like this, is an exact value. But in pre-calc, we usually, unless we state otherwise, we usually round to 3 decimal positions. You know, like with a radical, if it said radical 2, you would leave your answer radical 2. But a lot of times in pre-calc, we round to 3 decimals. So whether it's a natural log or a regular base log, they all work the same. All I did was change this b to a base 3, or a base 2, or whatever base you want to look at. Now the second one, you have to isolate this first. Before you can take the log of both sides, it has to be 1 term equals 1 term. Before you can take the log of both sides. So I have to get rid of this term right here. I can't do this. Don't write this down. I can't do this. I cannot do this. I can't take the log of each term. I have to condense this down to 1 term, 1 term. So I can get rid of this 5. And now I can take the log of both sides. I can use my power rule, bring it down. The ln e, the property is 1. And again, I can put that in my calculator and round to 3 decimals. Same thing if I did this with a log. I cannot take the log of each term. I can only take the log of each side. So I have to break this down, get this isolated by itself, get 1 term, 1 term. And again, I can take the log of both sides. You can take the ln of both sides here, you can take the log of both sides. Bring this down and divide both sides by log 3. They work the same. Good? Okay. So you can put logs on each term, you can take logs away. All right, let's hit another one. Excuse me. All right. Now, you have a couple of choices here. We are 1 term, 1 term. You can take the ln of both sides, and then you can use your product rule. You can do it that way, which is the way we probably should do it. Or we can isolate this and divide by 4. Just leave it 5 divided by 4. 5 divided by 4 is terminating, so if you brought it to a decimal, that'd be fine. If it doesn't bring to a decimal, don't leave it as a fraction. Now you can take the ln of both sides. I don't know why I can't write today. Bring this down. This cancels out. You can take the ln of 5/4. It's still greater than 0. It still has a log. And now what do I do? Divide by 2. Or you can do this the other way. You can use your product rule. This is the better way. This is the cheating way. Still okay. Still okay if we did this. Then we can subtract ln 4 from both sides. And we can do the same. Bring this down. Divide both sides by 2. And that works out the exact same, because isn't this now a quotient? And wouldn't this now be ln 5 minus ln 4? Right? We just took a shortcut. It's not illegal. We just took a shortcut. Technically, this probably is more better. It's probably, algebraically, it's probably a little bit wiser to do that, but we can do this without a problem. You probably did this last year, right? You didn't do these last year? Is this making sense? Reagan?
So would you rate your final answer like that or?
Oh no, you have to put this in your calculator. Yeah, just put it in your calculator. What is the final answer? 0.112. Sorry. But do you see that it's the same either way? Either way. So if you take a little shortcut, not a big deal. Okay. Just don't, if that's not roundable, don't round it. Okay. So again, now, that I had logs on both sides. This time, I have logs on one side. So I can't get rid of that log, and I can't put a log on the other side. I can only put a log on both sides. I can only put a log on both sides. If I have this, I can't put a log on that side. Okay, can't do that. So somehow I've got to get everything to one side, and I have to turn this into an exponential equation. So I'm going to isolate this right here. Just leave that there for a second. Now let's work through this. I want to be able to change this log. So what am I going to do with that 2? Where did that come from? It was an exponent. So I'm going to bring it back up. Now, I have a log on both sides. If it said that, what would you do? How would you convert this? You have a log on one side. How would you convert this and get rid of your log? Good. So this is my log equals exponent. Line this up. 10 is your base. -1 is your exponent. Equals x squared. It probably looks a little bit better looking at it that way than it does looking at it this way right now. But it's the same process. What is the base on this ln? E. So e to the -1. And how do I get rid of the square? Square root. So you're going to put this in your calculator. I have the answer to this. The 0.607. Okay. You can also, if you were here, I don't want to confuse you, but if you were here, mathematically, can I divide both sides by 2 rather than bring it back up there as a square? And then you can flip e to the -1/2 and get x. The -1/2, isn't that the same as my radical? Isn't my radical say e to the -1/2? Okay. So there's a number of ways you can probably get around these things. But if you have a log on one side, the only way to get rid of that is to isolate that to one side and flip it to an exponential equation. You can't cancel it out. You can't put logs on the other side. And also, the E is always hard to recognize. And if I took this base 10 out, that's another tough one to recognize. Because kids sit and look and say, where's my base? Don't forget. If it's not there, your base is 10. If it's not there, your base is E on the ln. So, excuse me. If I did this, this is probably a little bit more recognizable. 4 to the -1, because you could see the base. But don't forget, if it's not there, in logs, it's 10. In natural logs, it's 8. And the third type of problem you're going to get is when there's logs all over the place. So it looks like this. Now, you can't start by saying, okay, get rid of my logs. You can't do that. You can only cancel when it's one term, one term. So the first thing we have to do is turn this into a product. We're going to bring this down to one log. Put a line. This is where it really helps. Put a line down your equal sign. You got to get one side. Did you guys do proofs in geometry?
Yes.
Remember when you started off with those big long things and they came down to one thing, one thing? Basically, that's what you're getting down to. However long this needs to be, you have to get down to one thing, one thing. They're not going to be equal, but you have to bring it down to one. So, so I heard somebody say when you added your exponents, you were multiplying. So here's your multiplication rule. If you want to, you can just put an extra set of parentheses here. What do I do to that side? Bring the 2. I got to get rid of that 2. I can't cancel out that ln with that 2 sitting there. So that ln was technically an x squared. So now, how many terms do I have on the left-hand side? 1. So now I can say cancel out, cancel out. So you are left with this. You have a regular algebraic equation, and you have to solve it. How would you solve it? Can't divide by ln. Can't divide by ln. It's kind of like you can't divide by a variable, right? Can't divide by ln. You can only use your log rules to get down to here. So here's the situation. You can, remember, you can put logs on both sides. You can take logs away from both sides, but it has to be one term, one term. I can't just at random say, oh, let me get rid of these logs because they're all ln's. Can't do that. I have to have one term, one term. Now, so how would I solve this? You would get everything to one side, so you would equal it to 0, distribute this, distribute that, get everything to one side, factor it again. Do you need to do that part? I'm just going to tell you what the answers are. It all factors, and then it comes down to this. So when we factor, we're here. You're going to have to FOIL this out. I just skipped a step. Take away your x squared, and then you end up, combine this, you end up with this. I just skipped that step. So, because my goal is to get down to here. So here's my answer. Just like in anything that you do exponentially, when you change anything, you have to check your answers. You can have extraneous roots. So come down here and plug a 6 in. Just go into your arguments. 6 minus 2 gives me a 4. Can I take the log of 4? 6 times 2 is 12 minus 3. Can I take the log of 9? Can I take the log of 6? Yes. So 6 probably works. I can check it in my calculator because you can put the whole thing in your calculator. Or plug it into your L1, L2. Check it that way. Wait, one thing, guys. Let me check the 1. 1 minus 2, negative 1. Can I take the log of a negative number? No. So I have to say reject.